Hello everyone, I am Dr. Godandaraman. In this section we are going to discuss with formula for unit 1 random variable probability and queuing theory. First of all, basic definition. So definition of probability. The definition of probability, three different type of definition. So one is mathematical definition, statistical definition and axiomatic definition. So probability having three definition. One is mathematical definition of the probability is nothing but probability of A equal to m by n. M is nothing but number of favorable event by total number of exhaustive event. So favorable event by sample space. And then statistical definition of probability, the probability of even limit n tends to infinity m by n. So n is a trial and even e, this is a even, and then m is number of times. This is a statistical definition. Then axiomatic definition of the probability, three axiom. One is every probability of the event non-zero, and then total probability value 1, and then if a1 a2 up to an are finite number of disjoint even of S, then probability of A1 union A2 union up to union AN equal to probability of A1 plus probability of A2 up to probability of AN. So this is our basic definition of the probability. And then law of probability. What is the law? Law of probability. The law, addition law and multiplication law. Addition and then multiplication. So the addition law, multiplication law. In the addition law, two cases. One is when the mutually exclusive, case 1, addition law, mutually exclusive, when the events are mutually exclusive, when the events are mutually exclusive. So mutually exclusive is nothing but probability of A union B, probability of A plus probability of B. So this is when it's a mutually exclusive event. This is the formula. And the case 2, when not mutually exclusive event, when the events are not mutually exclusive. Mutually exclusive is nothing but probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. And multiplication law, case 1, when the events are independent. Multiplication law, when events are independent. So independent is nothing but probability of A intersection B, probability of A into probability of B. So this is a formula for multiplication, case 1. And case 2, when events are dependent or conditional probability. The probability of A intersection B equal to probability of A given B into probability of B. A given B into probability of B or probability of B given A into probability of A. So this is the multiplication law. Now random variable. The random variable is nothing but when the outcome many random experience may be non-numerical. So two cases we consider, one is discrete random variable and continuous random variable. Discrete random variable, then continuous, two type of random variable. Now we can see the formula for discrete random variable. Discrete random variable, probability of mass function. Probability of mass function is nothing but short form PMF, probability of mass function. The total probability value 1, x range minus infinity to plus, total probability value 1, and then mean of x, the mean expectation average is nothing but expectation of x equal to summation x into p of x, the x range minus infinity to plus infinity, and then variance. So variance is nothing but variance of x equal to x square minus e of x whole square. So we know e of x value, this is a formula. Now what is the formula for e of x square second moment? E of x square summation x square into p of x. So this is a second moment. Now should write here e of x square summation x square p of x, x range minus infinity to plus infinity, and then moment generating function, So the moment generating function e of x mx of t equal to summation e power tx probability of x, x range minus infinity to plus infinity, and cumulative distribution function. This is a short form MGF, moment generative function MGF, and then cumulative distribution function, CDF, distribution function, capital F of x equal to probability of x less than or equal to x, summation of probability of x minus infinity up to x. So these are the formula for discrete random variable. And the continuous random variable, So the continuous random variable is nothing but probability of density function, PDF, probability of density function, total probability minus infinity to plus infinity, f of x dx value 1, and then continuous is a integration. So mean of x, integral minus infinity to plus infinity x into f of x dx. This is the mean expectation of x, e of x. And variance of x, v of x equal to x square minus e of x whole square. So e of x, how to calculate here? Integration minus infinity to plus infinity x square f of x into dx. So this is a variance. And moment generating function, mgf, capital, this is a m x of t integral minus infinity to plus infinity e power tx f of x dx, and then cumulative distribution function, CDF is nothing but capital F of x, probability of x less than or equal to x, minus infinity to up to x f of x dx. So this is a formula for continuous random variable. And then properties. So properties of expectation. The properties of expectation is nothing but, now we consider here a b constant and x y variable. Therefore expectation of constant, expectation of a constant is constant, expectation of a into x, a expectation of x, and then this is the properties of expectation. Then expectation of ax plus b equal to a into expectation of x plus b, and expectation of x minus x bar equal to 0, expectation of x plus y equal to expectation of x, expectation of y. This is the additive property. So when independent, if x and y are independent, then expectation of xy, expectation of x, expectation of y when a and b are independent, that is x and y are independent. And then properties of variance, properties of variance. So the properties of variance is nothing but, here also a b constant, x y variable, therefore variance of constant 0, variance of constant 0, and then variance of ax equal to a square variance of x, variance of ax plus b equal to a square variance of x, variance of ax plus by equal to a square variance of x plus b square variance of y. So these are the properties of variance. And cumulative distribution function property, CDF properties. So when the probability of, if f is the distribution random variable, if a less than b, a less than x less than or equal to b, a less than x less than or equal to b, both less than or equal to, and a less than x less than b, and a less than or equal to x less than b, whatever the form, f of b minus f of a, and then the value f of minus infinity, that is distribution function one dimensional random variable, f of minus infinity equal to 0, f of infinity equal to 1. Then PDF, when the given capital F of is cumulative distribution is given, to find the PDF d by dx of capital F of x, d by ds capital F of x. So these are the properties of cumulative distribution function. And then moments, formula for moments. So moments about the origin, moment about the origin. So moment about the origin is nothing but raw moment. The raw moment when discrete, and then mu n dash equal to expectation of x power n summation x p of x, the x from minus infinity to plus infinity. This is the mu n, as usual mean. And then continuous mu n dash equal to expectation of x power n integral minus infinity plus infinity x power n f of x dx. So this is the x power n. This is the moments about the origin. And moment about the mean, this is nothing but central moment. So here also discrete and continuous. Discrete mu n equal to expectation of x minus x bar whole power n. This is nothing but summation x minus x bar whole power n into p of x, x minus infinity to plus infinity. And the continuous mu n equal to expectation of x minus x bar whole power n integral minus infinity plus infinity x minus x bar whole power n f of x dx. This is the moments about the mean. So the relationship between moments about the mean and moments about the origin. Relationship between moments about the origin, and moments about the mean, So this is nothing but mu 1 equal to, that is a mu r equal to mu r dash minus r c r c1 into mu r minus 1 dash plus rc2 mu square mu r minus 2 dash and so on. This is a general form. From this general form, mu 1 value 0, mu 2 it's a variance, mu 2 equal to mu 2 dash minus mu 1 dash square, then mu 3 equal to mu 3 dash minus 3 mu 2 dash mu 1 dash plus 2 mu 1 dash q, then mu 4 equal to mu 4 dash minus 4 mu 3 dash mu 1 dash plus 6 into mu 2 dash mu 1 dash square minus 3 into mu 1 dash power 4. These are the relationship between the moments about the origin and moments about the mean. And some properties of moment generating function. Properties of moment generating function MGF is nothing but the relation mx of t equal to 1 plus t mu 1 dash t square by 2 factorial mu 2 dash and then t power r by r factorial mu r dash and so on. For here, where mu r dash equal to the coefficient mu r dash equal to, this is a coefficient. So the coefficient of t power r factorial in moment generating function. This is a moment generating function. And some note from the moment generating function: when mu r dash is nothing but mu r dash equal to d power r by dt power r mx of t, then t equal to 0, and then moment generating function cx, suffix cx equal to cx of t equal to mx of ct, and then moment generating function x equal to a of t equal to e power minus at mx of t. So these are the some note for finding the moment generating function. So still now we have discussed probability basic concept, law of probability, discrete random variable, continuous random variable, and the properties of expectation, variance, cumulative distribution, and moments generating function relations. So now next, Chebyshev inequality and the function of random variable. Chebyshev's inequality. So the Chebyshev inequality, the main purpose to find the lower bound, upper bound. When the distribution is not mentioned the problem, we can find the lower bound and the upper bound. The definition is nothing but if x is a random variable with mean e of x equal to mu and variance v of x equal to sigma square, and then x minus mu modulus of greater than or equal to c, and then less than or equal to sigma square by c square, or x minus mu less than c greater than or equal to 1 minus sigma square by c square. So this formula is mainly focused to find the maximum upper bound, this is a lower bound, or other form, alternative form. The alternative form is nothing but, so in this case, if we put c equal to k sigma, here k is greater than 0 value, then the form x minus mu modulus when c k sigma greater than or equal to k sigma less than or equal to sigma square by c square is k square sigma square. When to cancel this, so this is a value 1 by k square, 1 by k square, or now the another form x minus mu less than k sigma then greater than or equal to 1 minus sigma square by c square, so 1 by k square. So this is a formula for Chebyshev inequality. And then function of random variable, next formula, function of random variable for one dimensional. The one dimensional is nothing but f of y equal to f of x into dx by dy. So dx by dy modulus fx of x. So this is a formula for unit 1 random variable. Thank you.